Object-oriented programming is one of the most effective approaches to writing software. In object-oriented programming, you write classes that represent real-world things and situations. And you create objects based on these classes. So when you write a class, you define the general behavior that a whole category of objects can have. So when you create individual objects from the class, each object is automatically equipped with general behavior. So you can then give each object whatever unique traits you desire. And you will be amazed how well real-world situations can be modeled with object-oriented programming. So making an object from a class is called instantiation. And you work with instances of a class. So in this section, you will write classes and create instances of these classes, and you will specify the kind of information that can be stored in instances, and you will define actions that can be taken with these instances. So you will also write classes that extend the functionality of existing classes. So similar classes can share common functionality, and you can do more with less code. So you will store your classes in modules and import classes written by other programmings into your program files. So learning about object-oriented programming will help you see the world as a programmer or coder does. So it will help you understand your programs, and not just what's happening line by line, code by code, but also bigger window here and bigger concepts behind it. So knowing the logic behind classes or object-oriented programming will trait you think logically, so you can write programs that effectively address almost any problem you encounter. So classes also make life easier for you and other programmers, and you will work with as you take increasingly complex challenges. So when you and other programs write code or programs based on the same kind of logic, you will be able to understand each other's work, and your programs will make sense to the people you work with, allowing everyone to accomplish more. So you can model almost anything using classes. Now we will write a simple class, which here we will create a car. That represents car, but not one car in particular, but any car. So what do we know about most cars? Well, they all have car makers, they all have models and years, and we also know that most cars are automatic or manual, right? So use three pieces of information, which is car, model, make, and year, and those behaviors, which is automatic and manuals, will go in our car class because they are common to most cars. So this class will tell Python to make a new object representing a car. After our class is written, we will use it to make individual instances, so each of which represents one specific class. So now we're going to create a car class. So each instance created from the car class will store a car model and make. This will be the same variable and year, and we will give each car the ability to drive and stop. Or actually, we can also add automatic and manual, but yeah, we will decide that here. So class car here, class car, and here we will add just a simple program that that written for cars, and here we will use init, but you will learn what init is. So init here, and we will add self name or car model make and model, car make and model, and after that we will enter the year, and after that we will, here we are initializing make and model year, And let's actually add the gearbox also, right? Gearbox. So here we will add gearbox. So gearbox can also be automatic, manual. CVT is a different kind of gearbox, but it's still gearbox, right? But in this case, we will add just automatic and manual gearboxes in our cars. So we will also define a new, but inside the car class. So here we have this indentation. So here we will define inside this car class the drive. Here we will use self, and that you will understand what these keywords are. And print here self dot name. Oops, inside the braces here, self dot name, or self dot make and model, and is now driving. And also we will use make and model. Also we will add year, self dot year, and also we will add self dot gearbox. Gearbox is now driving, right? So for example, BMW 2015, BMW 528 E here, year 2015, and gearbox is automatic, is now driving, right? And after that we will add another here, another function, which is going to be, let's stop here, right? Let's stop driving, and here we will also add self. So here we will print here with format, and we will copy this. Actually, let's, instead of copying this, let's write this right now here. Self dot car make and model, make and model, year, and so gearbox is stopped. That's it. So now I will explain this one by one. So here, oh sorry, it will not return anything because we didn't use this class. We just defined it. We are not using that yet. But here, let's first explain it, and then let's create examples from it. So here, there's a lot of notice here, but don't worry. So you will see the structure through this course, through this section, and have lots of time to get used to it. So first, we define a class called, here we define, oh sorry. So we define a class, sorry, here. Let me actually use my marker. So here we define a class called car. So by convention, capitalized names refer to classes in Python. So there are no parentheses in the class definition here because we are creating this class from scratch. So we then write the doc string. So this doc string here describing here what class does. So actually, let me write this here, doc string. This is a doc string here, and so here we are here seeing init method. So here, oops, actually here. So a function that's part of a class is method. Everything you learned about function applies to methods as well. The only practical difference from now is the way we call methods. So the init method here, the init method you are seeing here, actually let me use different color. this init method here, let's make it bigger so you can see the characters. So this init method here is special method that Python runs automatically whenever we create a new instance based on the car class. So this method has two leading underscores and here two underscores and two trailing underscores. A convention that's helped prevent Python's default method names from conflicting with your method names. So make sure to use the two underscores on each side of init. So if you just use one each side, the method won't be called automatically when you use your class, which can result in errors that are difficult to identify. So here we define init method to have three parameters. No, actually 1, 2, 3, 4 parameters. The self, actually let me, yes, here, the self, make and model, year, and gearbox, right? So the self parameter is required in the method definition, and it must come first before the other parameters here. So this should be first, as I said. So it must be included in the definition because Python calls this method later to create instance of car, and the method call will automatically pass the self argument, and every method call associated with an instance automatically passes self, which is a reference to the instance itself. So it gives the individual instance access to the attributes and methods in the class. So when we make an instance of car, Python will call this init here method from the car class, and we will pass car a make and model, a year, and a gearbox as arguments. And self here is passed automatically, so we don't need to pass it. So whenever we want to make an instance from our car class, we will provide values for only the last parameters, which is make and model, year, and gearbox, and not self here. So the two variables are defined in the body of the init method. Each have the prefix self here. Here, self, self, and self. Self, actually not this, here, self and self, right? So any variable prefixed with self is available to every method in the class, and we will also be able to access these variables through any instance created from the class. So the line self name here, the line self make and model here, actually let me write another code here. The self make and model, oops, actually let me we will write this here. Self make and model equals make and model here. We will get an error here. Here, self make and model. We will do it inside this. So here, oops, actually let me delete this here. So here, self, the line self make and model equals make and model takes the value associated with the parameter make and model and assigns to it the variable make and model, which is then attached to the instance being created. So the same process happens with the self, for example, year or gearbox equals gearbox, and the variables that are accessible through instances like this are called attributes. So the car class has two other methods, which is drive and stop driving. Because these methods doesn't need additional information to run, we just define them to have one parameter, which is self. So the instances we create later will have access to these methods. In other words, they will be able to drive and stop here. And for now, the drive and stop don't do much, and they simply print a message saying that our car model, year, gearbox is stopped, or in drive here, make and model, year, gearbox is now driving. So, but the concepts can be extended to realistic situations. So you can, for example, do it for a computer game or real world applications. or so on, which you will learn in next lectures.